This magnesium and titanium skateboard wheel is spinning dangerously fast.
Oy boy!
Today we're diving into the realm of extreme speed and danger with our most advanced skateboard wheel yet.
My life just flashed before my eyes.
We combined two of the lightest materials to make a wheel so fast it kept blowing up our ceramic bearings that were literally designed to go fast.
This is what remains of the ceramic bearing.
To get you up to speed, we started with a normal skateboard wheel, and that blew up violently, but it looked really cool in slow motion. It was going about 45,000 RPM when it blew up, so we decided to see if we could go faster. I made one out of aluminum, and that got going 50,000 RPM.
Holy crap!
But I wanted more. So I made one out of titanium, and that got going like 45,000 RPM. It was actually slower because it was heavier. So today I'm going to make a wheel out of magnesium, which is even lighter than aluminum and is surprisingly strong. There's only one problem. It likes to catch on fire and burn at over 5,000 degrees.
Holy
crap. To start us off, I want to do a little demonstration to show just how important it is that these wheels are perfectly balanced. I made a wheel out of pure resin, but I threw in a quarter to throw off the balance just a little. Let's see how much of a difference that makes.
It definitely wants to keep that quarter at the bottom.
Yeah, it's probably gonna blow up.
2, 1.
Oh boy!
I heard pieces of skateboard wheel raining down around me. What a rush. Like 2 hours of setup for a 3-second experiment. Oh, I found the quarter. I got so many little pieces.
Let's watch that slow-mo, shall we?
Okay, yeah, you can definitely see that the wheel is shaking all over. Oh, and there it goes. Oh, wow, the water splashing off is so cool. The resin wheel with a quarter in it got going 36,200 RPM. I think it definitely blew up faster because it was off balance.
Now that we know how important balance is, let's talk about the magnesium skateboard wheel. To start off, I was faced with the challenge of even getting my hands on some. You see, aluminum is really easy to buy. Titanium is a little more exotic, but you can still get your hands on it fairly easily. But magnesium is something else. It's extremely expensive, and although it's strong, it's relatively soft, which makes it unusable for most applications. This left me with only one option: watch eBay listings like a hawk until I could find something. Hey! But after 6 months of patiently waiting, I finally found the perfect piece. So I'd just go ahead and order it straight away, right? Not so fast. By now you all know the drill. I lowballed him. He accepted the very first offer. What a Jimmy. This is so crazy lightweight. If this were steel, it would probably be like 50 pounds. I don't know, because this whole entire massive rod is 14 pounds, 2 ounces, or 6.4 kilos. Here's how much it would weigh if it were steel. Magnesium is about 3 times lighter than titanium. That is nuts. Now, like I mentioned earlier, magnesium's a little soft, but I've got a plan in mind for that. All right, so we got our hands on, So obviously I can't just throw this in the lathe and turn it because it's huge. So we'll cut off a section of it and then put that in the lathe. So magnesium on the machinability scale is right here, a little bit softer than aluminum. Ooh, look at the steam coming off the Waterjet nozzle. Ooh, wow, that is a clean cut. We barely even have to do any smoothing with the lathe. Now that we have a much more manageable size, let's go throw this on the lathe and get down to business. We can use the Waterjet to cut this down to size and have the perfect circle. Why don't we do that? And it's gonna take roughly 23 minutes.
Here we go.
For this one, we turned on the 5-axis on the Waterjet so it could compensate for the angle of the stream and give us a perfect cylinder. But because it had no supports, it started falling. It looks like.
It started falling, it looks like.
Whew, that is clean. We might not have been perfectly centered, but that's all right. Then it was ready to be put on the lathe.
To the lathe.
Now, some of you may know that magnesium is a very dangerous element. And by that I mean it likes to catch on fire. I'm gonna try my darndest to not let that happen. But some of you may know I'm the world's worst latesman. Oh, I literally just crashed it. Turns out the magnesium rod wasn't totally straight when I cut it with the Waterjet. So I'm gonna have to correct for that on the lathe. If you do this step wrong, your entire lathing experience will be miserable.
There's a big hole right here from when it fell over and the jet started cutting. I didn't think it went that deep, but I'm looking at it now and I can't see the bottom of it.
I smoothed out the outside as well, because you also need that to be perfect or else your lathing experience will be miserable. Just watch how sick this is in slow-mo. It also kind of sounds like one of those new Amazon trucks backing up. Little by little I removed the surface from the cylinder, but I must have been doing something wrong because it started to look like a can of ravioli. Now normally I'd be amped to see my boy Chef Boyardee, but this time I wasn't. Oh, now that I've done all that, I can actually start working on the wheel. I started shaving it off again and got the same tin can effect. So I took a little break and did the front. And when I went back to do the outside, I did it by hand instead of using the half nut, or in other words, the lathe just moving it to the side automatically for me. That seemed to do the trick, so we're good to go. Palmer wanted to try, so at risk of ruining the entire project, I let him take a whack at it. Then I got the drill bit and drilled it a bit, and I made sure to rest my tripod against the same table the lathe was on so the footage would be really shaky. Now I need to make room for the bearings, which would normally be rather easy, but the electronic readout wasn't working. It gives you really precise measurements of your lathe movements. It's okay though, I just had to use the calipers 400 times. It finally fits, so now I can just put a nice little chamfered edge on the corner and move on. Now this is where the fun begins. First I'll cut the wheel part off the rest of the magnesium rod. I'll make a nice little line with my Sharpie, start cutting it with the cutoff bit, launch it off the lathe. Well,
Guess I didn't tighten the jaws enough.
Remount it, cut as deep as I could before realizing you actually can't cut it all the way off with this cutoff bit.
That's as deep as we can go. Dang, this is getting toasty.
Take it off the lathe, play hot potato because it's really hot now, then put it on the Waterjet and cut it there. While I had that all set up, I figured I'd cut off another wheel-sized piece and we could make a control for this very sophisticated experiment. Now I have to put it back on the lathe and smooth out the Waterjet cut. That's why I was trying to cut it off on the lathe in the first place, but here we are. Luckily for you, we can fast forward this part because it's definitely getting a little repetitive at this point. Trust me, I know, but it is oh so satisfying to watch the lathe do lathe things. Ouch. That is until your drill bit gets stuck in the middle of the wheel. I'm not smart enough to know why this happened the second time and not the first time. Luckily, I went to Gooners University, so I know how to get this one out. Okay, we'll just smooth all that out and that is nice. Nice. I'll make sure to get the drill bit stuck one more time, just for good measure.
Zooey mama.
Then I'll make room for the bearing on this side, and we're finally ready for the genius part of this plan.
That is nice.
This here is a titanium tube. I'm gonna try and take this and slide it over the end of the magnesium. So the majority of the wheel will be magnesium, making it really lightweight. Now, as it stands, the magnesium is this much bigger than the inside of the tube. So to get it that much smaller, I have to remove half, which is that much, 1 millimeter or 0.04 inches. And the electronic lathe measurement tool isn't working. So I have to remove that much by eyeballing it. So I spun up the lathe and took off little teeny tiny amounts until my calipers told me it was the right size. All right, I gotta cut this titanium tube down, so you already know where I am.
Ooh, sparky.
Titanium is always fun to cut on the Waterjet because you get dinner and a show, as long as you don't mind how crunchy it is. Oh man. That was inches from falling in. Then I sanded off the weld on the inside of the titanium tube because that would throw off the balance and make it harder to fit over the magnesium wheel.
Let's see if it fits. Like it almost wants to go on, but just not quite. I wonder if I could heat this up and fit it on.
I actually decided to do the opposite of that and cool the wheel.
All right, it's been in the fridge overnight. The freezer section of the fridge even.
Oh my god, and it's freezing cold. Goodness, dude.
But we're not gonna stop there. We're gonna go sub-zero on this bad boy.
All right, Palmer, have you ever heard the tale of acetone and dry ice?
I have not heard the tale of tone and ice.
All right, well, if you take some acetone and throw some dry ice in it, you have a poor man's liquid nitrogen.
Oh.
And we are poor men.
Yeah, we can't afford that.
Let me
Oh.
see.
I just connected the dots.
All right, go ahead and put that in there.
Do you want all of it or just some of it?
That's probably good.
Okay, let's do the fat boy.
Ooh, how splashy. We're gonna try and reuse this acetone. So I cleaned out our pot beforehand. Oh, you get splashed.
Yeah.
Oh,
No, I think
acetone in your eyes.
nasty. Well,
Lesson
do we
learned.
have are we OSHA sponsored and we've got the eye wash spray?
No. Before we do the wheel, let's use some water to demonstrate just how cold this is.
For good old experimental purposes, let's see how fast this water will freeze.
Avert your eyes. You don't want acetone. Oh, it's gonna blow up.
This is to prove how cold this is.
Well, it's already frozen.
Dang. What was that, like 30 seconds maybe? The reason acetone works where water doesn't is because the freezing temperature is lower. We need something to get this out with.
My hand?
You could. Yeah, let's go for it. We could heat up the titanium, but I think the magnesium should be cool enough. If
Here we
not,
go, you ready?
Yes.
3, 2, 1.
Oh, it's steaming. Uh-oh.
Give it a little tap.
Uh-oh. I don't want to like hammer directly on it, you know what I'm saying? Oh, that's going in like a dream. Not anymore. Wear your eye protection, kids.
You're there. You're in.
We got it. There we have it. Look at this.
Whew. It's a little dirty, but look how clean the fit is.
I kind of want to stick my finger in it. Oh, that's weird. It feels like an electric shock. Then we installed a Ford GT motor over my desk for some reason. I don't know. Looks cool though. All right, we have our sleeve on there. Now we just need to take off the edges because, yeah, hopefully this doesn't go poorly. This was real nice because the titanium was so thin it machined like butter. It did give me flashbacks to when I made the titanium wheel though. I just needed to smooth out the outside and try really hard to not run into the lathe jaws. Just look at how close that is. Then I flipped it around and did the same thing on the other side, and now this thing is ready to be tested. I wonder if you played this like a little tiny vinyl, if it would make any noise. I also made the control magnesium wheel, but it was basically the same thing, so we won't show all that. You can rewind the video a few minutes if you really want to see what it looked like. I did, however, make a very special wheel that I'd like to test as well. A viewer oh so kindly sent us this. I'm kindly showing off his address so you guys can send him some thank you notes. Anyways, this is a wheel of Kevlar. The guy who sent it to us said that he was working on a construction site on a high-rise or something, and on every floor they needed a safe room that could stop up to a rifle. So that's why we have 1.2 inches. So he suggested we make a skateboard wheel out of it. And I think that's a great idea. Making it was basically the exact same as the other three, except this time I used a vacuum because Kevlar splinters are just as bad as fiberglass, and I didn't want to get any bulletproof superpowers from the little tiny shards going into my skin and combining with my DNA. It's not super pretty, but I don't want to work with this nightmare material anymore. The most important part is that the bearings fit in it. And that it's round, past Daniel. You're trying so hard and doing so well, little guy. But I think our magnesium and titanium wheel will topple them all. All right, let's start with the Kevlar wheel. We've got it here. It's looking a little hairy though, so we better shave it.
Oh, that's not good to breathe.
Yeah, don't breathe this. Luckily, I have my Kevlar scissors on standby. Oh, look how much easier that is.
It actually does look easier.
I just gave myself 8,000 splinters. All right, I think we're good to throw this on. I think this won't explode. You know, we all know Kevlar could stop a bullet. This could stop a rifle round. So I don't think the rotational forces will be strong enough to rip every single layer of Kevlar off.
Yeah, I like your new leader hosing.
Oh, thank you. These are custom.
It took me a long time to edit the last video. I just kept having to look at this one certain clip.
We don't want this flying off and rolling all over the shop. We've got the slow-mo set to 60,000 frames per second. It's gonna look a little crustier because we have to crop in a lot.
Yeah, I'm nervous, man. These videos are so sketchy. I have my truck parked on the other side of the garage, so hopefully Waterjet channel will fix any damages if it goes through the wall.
You might want to move that.
Be safe, Daniel.
Thank you. Okay, here we go. Oh, man. Oh, man. sounds like it flew off. Oh,
Is it bouncing around?
I heard it bouncing around. Oh, there it is.
Oh, that was so loud. Don't breathe this.
Yeah, for real. Kevlar fibers.
Oh yeah, you can smell it. It smells like fiberglass being burnt. Here she is. Huh. There's a little channel, a little groove in there. Oh, you can see all the little sparklies on the wood. Those are all from the Kevlar. I gotta steal the nut off the Minecraft skateboard.
Bro, I don't think you need a hammer on it that much.
All right, I'm gonna start the jet.
Wait.
All right, here we go. Okay, it kind of sounded like it maxed out, and then it kind of started slowing down again.
Yeah, it sounds like the bearings went out.
That's still spinning, that's crazy. That was rather loud.
It was loud. I wanted to plug my ears out there through the door.
That's crazy.
The bearings look like they're intact.
So it looks like we reached our limit with the Kevlar. Let's look at the slow-mo and calculate our top speed.
Okay, that Kevlar looks rather unbalanced too. Oh, and there goes the nut that was holding it on. It's only a matter of time before this goes now. Oh, the bearing's starting to fly apart as well. Yo, there goes the bearing. And that really throws the weight off. It's just shaking so violently now. And, oh, I think it's flying up. There it goes. The Kevlar wheel was spinning at about 44,000 RPM.
Now before we do this test, let's put it all into perspective. A car driving on the freeway will have its wheels spinning 1,000 times a minute. A jet engine goes about 20 times that speed at 20,000 RPM. A Dremel can hit speeds of up to 50,000 RPM because the piece that it's moving is so small and lightweight. Our skateboard wheel is several hundred times heavier than the head of this Dremel. So let's see how fast we can get it going. All right, this is the pure magnesium wheel, no titanium sheath on it like this one.
I really hope it sparks up. Garnet on for that one, please.
Should we?
Come on, get on there. There we go.
All right, so for the magnesium wheel, since it's probably not gonna blow up, I'm just gonna let it start going real fast and stop it when it maxes out. I do need to pierce through the shield though really quick. Oh no, it came off. Oh dear. Oh my, it's right here. Oh, oh my. My life just flashed before my eyes.
Was it spinning and almost hit you?
It was caught like right here,
Oh
spinning
my.
around, and I didn't know where it was, so I walked out, and I'm standing like right here, and it's still spinning. Oh, the bearings exploded.
Oh, there goes the nut and part of the bearing. Oh, and what is that? Is that the inside of the bearing? I think it is. Those water droplets just freeze when the slow-mo footage slows down all the way. They're barely even moving. That gives you a perspective of how fast that wheel is spinning. The magnesium wheel got going 20,400 RPM, but I think it could have gone faster had the bearings not gone out.
Take a look inside this.
The bearing just got absolutely destroyed. There's one of the balls, and it looks like the outer ring is totally shreked. This one, same deal. This is what remains of the ceramic bearing.
That's insane.
The ceramic balls were moving fast enough to melt the metal. Check this out. I just noticed there's an entire trail from where the wheel went. Comes over here, bounces, makes a little crater in the garnet, and then it comes up here. You can see like a grain. What's that called? Like, as it chewed out, there's a little line from each rotation. Comes up here, it stayed here for a minute, and look, there's like a little piece dug out. It's like a millimeter deep, where it was just burning out for a second. Then over here, got stuck in the corner. I walked out and stood away from it, and then went off the side.
Face shield is required.
Yeah, where's the face shield? All right, here's the big daddy, the magnesium wheel with the titanium shell. It all comes down to this. Will this actually spin faster than a pure magnesium wheel? There's still a bearing on there. It's like stuck on. I can't get it off.
I think there's molten metal in the way. Look at this.
Oh yeah, I see that. It's like a little tack weld.
All right, here we go. Will we beat our maximum high-speed record with the magnesium and titanium wheel?
I have high hopes.
Me too. Okay, it should be lined up. As soon as I turn on the water, it should start spinning.
Oh boy, that's going fast. Oh man. It just keeps going faster. 90 pounds maxed out. I'm gonna adjust it yet. Okay, it's slowing down. I'm gonna try and get it back up to top speed and trigger it. Uh-oh. I think that might be going just as fast. Okay.
Holy moly. I honestly think, oh, look at all the smoke.
Oh my. Oh, that is some nasty smoke.
Wow, the bearings are completely gone, and the wheel is hot. That is like welded on.
Yeah.
There we go. Holy,
Oh, did you hear that?
oh, look at the wheel. It like, I get it wet, and it just immediately dries, and it all evaporates.
Look at that.
It just sheared it completely off.
That thing must have been cooking.
Oh, and the bearings are just torched in this one too.
Let's watch the slow-mo and see how fast that bad boy was going.
Wow, the magnesium and titanium skateboard wheel is zooming. It got going 59,000 RPM. That's insane. I think that's our new record.
It seems like on all these wheels, the failure point was actually the bearings and not the wheel itself. So we want to try this whole thing again with the best bearings money can buy, but that'll have to be in a future video. So subscribe to see that. Because if you don't do that, you're